Hello. So now you all understand how k-means clustering works. Let's talk about advantages and disadvantages of this algorithm. As you've seen, this is a rather simple algorithm, easy to understand and also easy to implement. In practice, it also converges very fast. So you'll see you don't have to go through hundreds or thousands of iterations. Usually after a couple of iterations, the algorithm converges and you have the final clusters. Because of this, it's quite efficient. If you want to analyze the time complexity, what you do is t iterations times k clusters times the number of data points. But now k is a constant. The number of clusters is fixed at the beginning. And because it converges so fast, t doesn't really become a variable. It's considered linear for practical purposes. So it grows with the number of n. And that makes it ideal. Even if you have very large data sets, you can still apply k-means clustering and it works quite fast, quite efficient. What are the downsides? Well, the first problem is you have to choose k. And you might not know for a given data set what a good choice of k is. Is it 3? Is it 55? Is it 61,000? Sometimes you know from the application, from the problem, from the data you're analyzing what a good choice of k is, but in other cases you have to experiment. It's sensitive to outliers. I'll explain this on an example on the next slide. And the way it works, if you run it multiple times, because you have these initial random centroids, you're going to get different results. So what you do in practice as a kind of data science analytic step, it's not enough to run this once. And then even with one value of k, you want to run it multiple times because you're going to get different results. So why? These last 2 points, it's easiest to see on some examples. So the first problem k-means has is that it has no understanding of outliers. You have these data points here, and there is one point that's far away from all the others. So that's an outlier. That might be a problem with the data, some incorrectly transferred data, some other error, some missing value. There can be all kinds of reasons for this. And in large data sets, you're always going to have some kind of problem. So what k-means is going to do for 2 clusters, it's going to try to put this into one cluster. So you're going to have one cluster here and one here. But this is kind of, if you look at the data points, kind of doesn't give you the right picture of the data. What you would rather have is one cluster here, and one here. But k-means doesn't know anything about outliers. It's just going to force all the values into the number of clusters you ask it to. It's sensitive to the initial random seeds. So the initial choice of the clusters. If you look at here, the data, this one and this one is exactly the same, but here we are choosing these 2 for the initial centroids, and here we are choosing these 2. And you can see that when you're clustering them, you're going to get different results. Here you end up with these 2 clusters on top of each other, and here you're ending up with 2 clusters next to each other. So this is why you have to run k-means several times, and you're going to get different results with each one. So be aware of this disadvantage. There is no perfect clustering algorithm. All of them have some advantages, some disadvantages. So as a data scientist, you have to analyze your data further. You have to understand your data, run different algorithms, and compare the result. In general, you can't say that one clustering algorithm is better than the other. They will give you different results. But again, like I said in the beginning, it's not like one cluster is correct and the other is wrong. So again, clusters like here, you might say, okay, I would like to have these two clusters, these grouped together and these grouped together. But k-means, for example, will group them in this way. We'll put these clusters together and these here together. So if you would like to have clusters like this, then you need a different clustering algorithm. So be aware, there is no correct cluster. In a machine learning course, you're going to learn more clustering algorithms. Here, we're probably not going to look at a lot of those because, again, this is covered in the machine learning course. So this is one initial analysis step in, for example, document analysis. Here's another example for a document clustering step where it's used to cluster research grant proposals. So NFS is the US National Science Foundation, and it's used to analyze the research grants, the applications for research funding, and group them together in different topics. And there is a nice demo for commercial text analysis engine, which you can also check out on YouTube and get a bit of an idea what you can do with clustering on documents. And then I will see you again in the next lecture part where we talk about classification and regression algorithms. See you then.